Hi, I am Varun Joshi and welcome to day 54 of our Certified Kubernetes Administrator 2025 course. Today, we will build a multi-node Kubernetes cluster from scratch using kubeadm. We will install containerd as the container runtime or CRI plugin and Calico as our CNI plugin. The installation of Calico will be done in the recommended approach, which is we will be using Calico Operator to install the Calico CNI plugin. We will do this on cloud VMs. We will be leveraging AWS's EC2 instances to create our multi-node Kubernetes cluster. But be assured that you can perform this demo in any virtual machine. So be it in your home lab, on premises, any cloud provider, or your laptop's hypervisor. Just ensure that the ports and protocols that we are allowing in our security groups, you also allow those in your firewall. In case you are using any other operating system than what we are using for the underlying nodes, then you would also have to do some tuning and tweaking, but at a very high level the steps that you perform will be pretty much similar, if not same. But be assured that since I'm using Ubuntu, you also use that if you want to follow the steps that I will use in this demo. With that said, let's go to the browser and see what are the prerequisites for this lecture. We are on day 54 and here are the prerequisites. The first one is you should understand the Kubernetes architecture. I do not have to answer why, because we in today's lecture will be configuring all these components, will be installing all these components. So it is of paramount importance that you understand what these components do, how the control plane and data plane components come in action to give you a fully functional Kubernetes cluster. So watch day 7 to have that understanding. And we also followed the deployment workflow in this lecture. And this is a favorite question for interviewers. Explain what each component is doing in detail, step by step, inch by inch, bit by bit. So if you can answer that, that's awesome. Then we have day 25. In day 25, we discussed how the Kubernetes architecture is modular. It's not that everything that is Kubernetes is done by the Kubernetes community. There is a core part in Kubernetes that is container orchestration, which is managed by the Kubernetes community. And then there are rest of the things. There are add-ons, there are plugins which are externalized. To understand how this modular architecture works and is beneficial and what exactly it is, I would recommend you that you watch day 25. I also have a 5-minute checklist. So if you understand these terms and how they fit in to ensure that your workloads are run properly, you are good to proceed with this lecture. With that said, let's get started and see what we are going to do. Build a multi-node Kubernetes cluster with kubeadm. We will be deploying version 1.32 of Kubernetes, 1 being the major version, 3.2 being the minor version, and .8 is the patch release, which we will see as we progress with this demo. We will be deploying 1 control plane node and 2 data plane nodes. So let's go to the diagram and understand what are we going to deploy. I scroll down. So here you see a control plane node and you see 2 worker nodes. Both of these worker nodes form the data plane. In case you have more worker nodes, they will also sit in the data plane itself. We have yours truly sitting here, Varun. Varun is the user who will be configuring the cluster, and once the cluster is configured properly, Varun will be verifying that indeed whatever is deployed as an application is accessible. And we know for local testing and development we use the NodePort service. Hence what I have done is, in my control plane nodes and in my data plane nodes, we have allowed inbound on port 22. Inbound implies incoming connections. If you have any confusions pertaining to inbound, outbound, how all these things fit into the bigger picture of networking, I would suggest you watch the network policies lecture, which is in the description box. Now, two ports we know inbound must be allowed. One is SSH, that should be allowed in both the control plane node and also the data plane node. That's one. Second is, in the data plane node, we also must allow the node port range. Now, in case you are using a specific node port, in that scenario, you will only allow that node port. But in my scenario, I will leave it to allow every node port, and then I will be deploying my application, and that application will receive a random node port, and that node port will already be allowed. Then I want to explore the communication between the control plane nodes and the data plane nodes, and also the communication between the worker nodes themselves. So let's see what we are allowing. Firstly, as we will be using Calico as our CNI plugin, we must allow the Calico ports. Calico uses port UDP 4789 when you are using the VXLAN mode. Here we are saying UDP 4789 is allowed bidirectional. So worker node 1 can access worker node 2 on this port, and vice versa is also true. That is, worker node 2 can access worker node 1 on UDP port 4789. Now this 4789 is also allowed bidirectional between the control plane node and the data plane node. Now if you are wondering from where did I get this information, I got this from the official documentation. So if I go to my browser and I go to this tab, system requirements Calico, you will see that 4789 bidirectional is required when VXLAN is enabled. So we will be using VXLAN. In case you use IP in IP, then you would need protocol number 4. In addition to that, if you are using BGP routing, you might also want to include TCP port 179 in the communication. And here it is mentioning which hosts should have this allowed. Since it is all, we know that when we are allowing UDP 4789, it must be allowed everywhere in our cluster. Hence we have done this. Then you have ports and protocols. This is from the official Kubernetes documentation, and from here I have picked the port I need for my implementation of Kubernetes cluster. The key word here is my implementation of Kubernetes cluster. If your use case is different, then you will have additional ports as well, and we will see when you will have additional ports. So let's go back to our diagram here, and what we see is Calico, as we have discussed. Then we are also saying our worker nodes are allowed to speak with the control plane node on port 6443, which is why we will be allowing inbound in control plane node on port 6443. Why is this needed? When your worker nodes will join the Kubernetes cluster, they will be accessing the control plane on port 6443. That's why we have this. And at the very last, you see control plane is allowed to communicate with our data plane on port 10250. Hence our data plane must allow inbound on port 10250. Now someone is wondering, I know, why would the control plane want to speak with the data plane? So why would the control plane speak to kubelet? Or in other specific words, why would the API server want to speak with the kubelet running in all the worker nodes? The answer for that is whenever you run kubectl logs or kubectl exec, your API server communicates with the kubelet on port 10250. Hence, this port must be allowed in all your worker nodes inbound. Now, this is what we will be doing in case you have these scattered. So what we are doing is all our control plane components are in the same virtual machine. Hence, we do not have to allow anything to speak with each other. So for example, we know that API server communicates with etcd. Since this is the local host, all of these components are in the same virtual machine, I do not have to specifically allow any communication between the API server and the etcd node. In case I would have deployed etcd outside, as in as a separate virtual machine, then I would have to allow additional ports. I will have to allow etcd in the etcd firewall. I will have to allow inbound on a specific port. So if I go to the documentation again, then you see here 2379 and 2380 are the ports which are used between the API server and the etcd communication. And another thing I want to bring to your notice is API server is the central point for all communication. Any component that wants to speak to another component, the communication goes via the API server. So keep that important distinction in mind. Now that we have the understanding of our architecture of what we are going to deploy, let's go to the AWS console and see how I have configured my security groups. So let's go to the browser, and here I have my security groups. I'll hit a refresh just so that you have the latest information at your disposal. You see there are two security groups created here. There is a control plane security group, and then there is a data plane security group. I want you to clearly understand that I have not created different security groups for my worker nodes. I have two worker nodes. I have not created two security groups for them because I want you to clearly understand that worker nodes come and go. If worker node 2 dies and worker node 3 comes up, there is no security group for worker 3. That is not something you want. Hence, what I have done is I have created a common security group. That security group will be associated with the ENI of any worker node that gets created for this implementation. So I have two worker nodes. Both of my worker nodes will be using this security group, and I only have one control plane node, and hence I have one security group. Even if I had multiple control plane nodes for high availability, I would still associate all of them with a single control plane security group. Now that we have that understanding, let's study the ports that we have allowed. So if I go to the control plane security group first, I will scroll to the right, and you see there are only three rules, 6443, and that's the beauty. Now I have the source that is allowed to communicate with my API server with my control plane node on port 6443 is my data plane security group. So anything, any ENI, any worker node that is associated with this security group is allowed to speak with my API server. Why with my API server? Because control plane SG is the security group that I will associate with my control plane node. In the second tab, I'm saying the same thing, but I'm saying this is for UDP port 4789, and 4789 will be used by Calico. Lastly, I am allowing inbound on port 22 from this specific IP address. Whose IP address is this? This is the IP address of yours truly. Now let's see what we have configured for the data plane security group. I'll go here, and here I have 5 rules. First 2 rules are self-explanatory. One is for SSH that yours truly will be using to SSH into the data plane nodes, and this rule is to test the application that we will deploy once the cluster is up and running. Then we have 4789. First 4789 allows the communication from the control plane node. Second allows the communication from the data plane SG. But Varun, we are watching the rules of data plane SG. I want you to create a mental picture in your head. If I go back to my diagrams, you have worker 1, you have worker 2. They both are associated with data plane security group. What I am saying is, when worker node 1 initiates a communication towards UDP port 4789 on this worker node 2, then this worker node 2's SG must allow that communication. And what is the security group that is associated with worker node 1? Worker node 1 has security group data plane SG. What is the security group associated with worker 2? It is the same security group. Hence, I am allowing communication on port 4789 UDP for data plane SG. This is a self rule. Last one is 10250, and this is from source control plane SG, and this is for kubelet communication as we discussed in the diagrams. Now that we have this understanding, let's go to the EC2 tab and create instances for us. I want you to know that I am logged in as varun.joshi. It's an IAM user, and then I am logged in into an account whose alias is cloud-with-varjosh-prod. Now what I will do is I'll click on launch instance. I will call this instance control plane as expected. Then I will choose Ubuntu. I would recommend you also choose Ubuntu if you want to follow step by step what I am doing. Then here I will keep everything at default. Then I will go to instance type. Now I will be choosing T3 medium for my control plane node, and I will recommend you do the same because kubeadm asks you to have 2 vCPUs in your control plane node. Now there is a way to bypass that flag. So when you are configuring your machine to be the control plane node using kubeadm, it will give you an error stating that your machine does not have 2 vCPUs in case you spin up a machine with 1 vCPU. There is a way to bypass that, but I want to follow the recommendations in this demonstration. Hence I am choosing T3.medium. So I'll click on it, and if you go to the GitHub repository, I have jotted down the flag that you can use if you receive an error and you are using 1 vCPU. And now is the interesting part, key pair. Now I have already created a key pair here, and I wanted to spend some time on this tab. Now you know that nomenclature is of high importance to me. Here as well, here is the account that I am dealing with, as in the project I am dealing with called Cloud with Varjosh. Then is the environment, which is prod, as you can see here in this account is for production. And then I have the region name, and then I have the last 4 digits of my account number, AWS account number. Now why I have named it like this, because if I watch this in this AWS console, I can figure out all these things, which region, which account number. But I want you to know, if I go to my terminal, you will have all these .pem files downloaded, and if you have multiple of these in your machine, you should be able to identify to which project this key belongs. Hence naming it properly is important. Now if you do not have this key pair already generated, then what you can do is you can click on here and generate ED25519 key pair. and then I will cancel this. I would suggest you that you also use your provider's mechanism to generate this key pair. In case you want to self-generate it using SSH keygen, then ensure that you also copy your public key in the authorized key file. And steps for that are also available in the GitHub repository. Now I will scroll down here. I want to choose the security group. The security group that I will choose is the control plane SG, because I am creating control plane node. I'll click here, I'll scroll down, and now I'll click on launch instance. Instance is launched. I'll come here. It is still initializing. And if I go to volumes, this is the volume that was recently created, 1237. It is 1237 on my clock. 8 GB. I have chosen this to be 8 GB, which is the default. If you want more, you can configure it accordingly. So I'll go back to instances. I'll click on this. I'll click on connect. And from here, I will copy this. And then my .pem file is located in the download. So if I click ls, you see it is here. I will put this command here, and then I will press enter. So if you are not in the directory where your file resides, .pem resides, then you will have to provide that path here. Another thing is you will have to give 400 or 600 permissions in your .pem file. So in case you don't have those, you can do this using chmod and then 400, and then you can provide the name of that file, press enter, and if you hit ls-la, then you see here is your permissions. So the owner only has read permissions. If you want to be a little more lenient, then you can provide read plus write using 600. Let me copy that command again from here. I'll copy it, I'll paste it here, I'll press enter, and I should be inside the virtual machine. It is asking me, are you sure you want to continue connecting? And if you have seen my SSH lecture, you know that we are doing tofu. Tofu is trust on first use. So we are trusting the fingerprint. There are other mechanisms which we discussed in our SSH lecture. If you want to know more about it, you can watch that. I'll press enter, and it is adding this into our known hosts. Now we are logged in. I'll clear my screen. The first step I want to do is I want to give this machine a proper name so that as soon as I see it, I know this is my control plane node. So I will go here and I'll scroll down, further down, and here is the command I want to run. I'll run it, and I will run exec bash. It's just a refresher for my terminal, and you see the name is here. Now let's go to our GitHub repository and see what we want to do. Now I have clearly called out what steps are to be performed in which nodes. So be extremely careful when you are applying these. For example, I have written disable swap and set kernel networking. This is supposed to be performed in all your nodes. So be it worker or be it control. Let's run these commands. So what we are doing is we are disabling swap, and we are preparing the kernel for Kubernetes installation. We are modifying certain parameters to ensure that our VM accepts the installation that we want to perform. So I will copy this, and then I will go to my terminal. I will paste it here. I'll press enter, and this is done. Now let's move to step 2. Step 2 is install and configure containerd. Containerd is our CRI plugin which we will use as our container runtime. So in the first step, we are installing containerd. In the second step, we are aligning containerd with kubelet's expectations. I want you to clearly know that when kubelet receives or asks API server about the specifications of the pods that must be configured, it communicates that information to the container runtime so that container runtime can pull the image that is needed and work with CNI to configure the networking. Hence, it is important that container D is configured in such a way that kubelet can seamlessly communicate with it. That's what we are doing in this step. Then we are performing few reload operations. Another thing that you can note from this is we are installing container D as a unit file, as a service. So now we will copy this and we'll go to our terminal and we'll paste it here. And this should show running and active to us. Perfect. This is active and running. I'll hit Q and then let's go here and let's see what we want to do in step 3. Step 3, again, all nodes. This is the point where all the action is happening. We will be installing kubeadm, then we'll be installing kubelet and kubectl. So let's copy this command and I will paste it here. And as you can see, everything that we are installing is of version 1.32, and then the patch release version is .8, which we will see soon. Let's go there and you see it is 1.32.8, the kubeadm. Kubernetes is 1.32.8. Client version, that is our kubectl client, is 1.32.8 as well. Now it is the recommendation that your major minor versions between the Kubernetes version and kubectl version should be plus minus 1. Then here is the customized version. We know that customize is built in the kubectl binary. Hence you also see customized version when you run kubectl version command. Let's go back to our browser and see what we want to do next. Bash completion, optional but helpful, and I always want this, so I will run these commands. I am not someone who prefers this alias. If you like it, like we have been writing kubectl getpods, if you want to write just k getpods, you can also install this alias. Now it is not what I prefer. You will be writing the CKA exam. If this saves you time, and it does, then go ahead and use K as an alias. I did it in my environment, but I have a habit of typing kubectl, so I could never get a hang of it. So let's go back here. It says it is done. Now let's see what we want to do next. Step 4 is the command that will tell this virtual machine that, my friend, you are the control plane, so take the responsibility. So let's copy this command. I'll go to Visual Studio Code. I will paste this here and I want you to understand this. First is we are saying this is the control plane endpoint. As we know, we have opened port 6443. It is the port on which our API server will be listening on. Then we are saying the advertise address for API server is this one. We will copy the IP address soon from our AWS console. This is the point I want to concentrate on. Understand that there is a separate subnet that we are saying this is the pod network CIDR. I will leave this here right now and we'll discuss more about this later. But I want you to remember this, that we have added a pod network CIDR, which is 192.168.0.0/16. So I'll go to the AWS console, and then from there what I will do is I'll copy the private address of this node and I'll go to Visual Studio Code again. I will paste that IP here and here, and then I will copy this and then I will paste this onto my terminal. I'll paste it here and it will take 30 seconds or even less. Let's allow it some time. It has installed successfully. Now this node is initialized as the control plane node. So what I'll do is, it is saying to start using your cluster, you need to run the following as a regular user. What are we doing in this step is, we are creating our kube configuration file. Now, if you have any confusions about kube configuration file, then you can watch the attached lecture. But the important thing is, whenever you are connecting with your API server, it is the kube configuration file that is used by your kubectl client to perform authentication. It is used to authenticate the API server as well, and it also holds the certificate which you present to the API server to confirm your identity. Even if we are in the control plane node, we will still have kube configuration file when we want to use kubectl client to connect or send commands to our Kubernetes cluster, because that is basics of authentication, which we have discussed in greater detail in our TLS section of this course. So for now, I will just copy this and I will paste this here. I'll press enter and this is done. I can now run kubectl get nodes and it will not show me the nodes. Let's allow it some more time. Let's run kubectl get pods. If this doesn't run, then we should allow it some more time. 43,189, 43,189. Let's go to the console. It's 43,189. Now let's run again kubectl get pods. Show me something, man. Let's do some basic troubleshooting. Let's run kubectl get pods once again and then we'll do something. Let's run kubectl. Let's run sudo systemctl and then I want to see status of first kubelet. Kubelet is running. Error syncing pod, failed to get status, and these messages were a while back. Okay, this looks okay to me, but right now the service is running just fine. Then let's check the status of container D, and that should not matter because we are not able to connect with the API server right now. The error is different. kubectl get pods. Let me check if any step is pending. I'll go to my browser. I'll go to this. We have run this. No, CNI we have not installed. We don't want to install that right now. Here it said initialized successfully, and then kubectl get pods. If this doesn't work, I'll take a reboot of this server. Sudo init 6. See, in my practice sessions preceding to this lecture, there was never a successful installation. Never. I had a different error all the time, and if you visit the GitHub repository, you will see what all things I did to get rid of those errors. Mostly it was I reconfigured something, because see, I want you to know that there are hundreds of services involved in order to ensure that everything works as expected. Now, at times there is a possibility that something gets hung here and there. In that scenario, a reboot will help, or reconfiguring that service will help. At this stage, when you are creating a development cluster, then it does not make sense to spend all your energy in troubleshooting. You have to choose your battles wisely. In case you face problem with your production cluster, then of course you work, troubleshoot and fix the problem. But when you are dealing with development workloads, to save on time, the first thing is you try a reboot. Then the second thing is you try to reinstall that service or component. And I have jotted down the steps in the GitHub repository on how to do both of these. So for now, let's see if this reboot helped us or not. In case it didn't, we'll have to do something else. Now let's run kubectl get pods, and you see a reboot reinitialized everything, and it is working as expected now. So let's run kubectl get pods. No pods in the default namespace. Kubectl get nodes. There is one node. The status is not ready. Kubectl get pods -a. Pods are running, but they have restarted a few times, which is fine. The cluster is recently created. Control plane node is recently created, but I want you to observe a few things right away. First is the core DNS pods are in pending state, which implies the scheduler, which is in running state, has not even scheduled the core DNS pods. First point is this. Now these pods are running and all of these are in healthy state. Why do I know these are in healthy state? Because the status here is 1 on 1. All of these pods, they only have one container, and that one container is up and running. So let's run this command again, and you see it is still fine and the number of restarts has not changed. Now I want to run one more command. I will run kubectl get pods -a-o void. Now why I am running this is, firstly, I want to show you that all of the control plane components along with the kube proxy which is running as daemon set, has the IP address of the node itself, of the control plane node itself. So if I go to my AWS console, you see that our node has 43.189 and this is 43.189. Again, we have received the IP address from the VPC CIDR, which is obvious, but any workload pods that we create will have IP address from this subnet, and we will see that as we progress with this lecture. Now at this stage itself, what I want to do is kubectl create deploy. I will call this a web, and I will say that I want this to use image of nginx, and then the replicas that I want are 2. I'll press enter and this will create a deployment. And if I run this command kubectl get pods -a, then I see there are 2 web pods created as we asked, and these pods are in pending state. So now I want you to note that the core DNS and the web pods are in pending state. Rest everything, our control plane is up and running. If I run kubectl get nodes here, I still see the status is not ready. As soon as I configure the CNI, this status should ideally change. So let's go back to our browser. I will come here and then I will install the CNI. So what we are doing is we are using operator for this installation, and what we are doing is we are saying that here the CIDR for the pod networking is 192.168.0.0. If I had mentioned something else here, then this would have errored out, because what we have defined in our command is this CIDR. Hence this CIDR should match what we are defining here. Now if you are not sure, because this one is also the default for Calico will choose this CIDR for your pod network, but if you are not sure about the defaults, then you do not have to mention this. But if you do mention this, then whatever the pod CIDR is for your CNI, for Calico the default is this, but for Flannel or if you're using any other CNI, you will have to check the default for that and then run it, because these two should match. Or if you are not sure, do not put this at all. Now I will copy this and I'll go to the terminal and I'll paste it here. I'll press enter and this will install a lot of things. And now I can run the same command again, kubectl get pods -a. Now when I run this, you see there are a lot of pods created. Here is the Tigera operator, and then you have Calico node, Calico Taifa, Calico Cube controller, and so on. Now I want to clarify a few things right away. This is something that you need because this and the controller, they both are required here. But Calico node, let me also run kubectl get ds -a. I have run kubectl get daemon set. I will also run kubectl get deploy -a so that you know what is deployed as what. I want to call out right away. Tigera operator is something that we will use. Calico Taifa we do not need, but this comes with the installation. Then you have cube controller, Calico cube controller. This is something that we need. Then if I talk about daemon set, CSI node driver is something that we do not need. Now I want to mention a few more things. What I have done is I have specially instructed this command that we have run here to not install anything extra. So we have used this command, but if you go to the documentation, you will be installing a lot of things. So if I copy this, what I have done is I have only installed a section from this. So if you see the default one, I will quickly paste it here. And if I cat this file custom resources, then you see it was installing these things as well by default, but I have not installed any of these. We have just installed this part. Now if your installation warrants these things, then be my guest, but your installation should be minimal. We still have Calico Taifa and CSI node driver. We don't need these things. Now based on discussions with Tigera, you can ask them how to remove them. You can either directly remove this deployment and daemon set, or you can ask them to give you an installation bundle or installation manual that will not include these. Now I could have done this in such a way that these were not installed, but that would have made things a lot more complex. Hence I will leave this to default, but I want you to concentrate on one thing. kubectl get pods -a. Now you see there are two pods that are in pending state, and these are our web pods, but the core DNS pod are in running state, and they came in the running state as soon as we configured the CNI. And why is that? So to answer that question, let me run kubectl get pods -a-o wide. Here you also see the IP addresses of these pods. You see the core DNS pods, they have an IP address 192.168.235.132. I want you to clearly understand this IP is from the pod cider. So core DNS pods were awaiting the CNI to come and allocate the IP addresses to this pod. I want you to again understand that it is the kubelet that tells the CNI, configure the networking for this pod, give me the IP address, assign the IP address, and it is CNI's job to do IPAM and to only allocate IPs that are unique and available. Hence, core DNS only received the IP address once the CNI was configured. So this is understood, Varun. But why are my web pods still in pending state? Because now we have means via which they can be assigned IP addresses. But why are still they in pending state? They are in pending state for a different reason. You know that the control plane node has a taint which prohibits pods to run onto the control plane node until and unless they have a toleration for it. Now the control plane node has a taint for which our web pods do not have toleration, whereas the core DNS pods did have toleration for the taint that is there in the control plane node, which is the reason our web pods are still in pending state. Now what we want to do is we want to create worker nodes so that our web pods can be scheduled and our website can be accessed. So let's go to the AWS console. I'll click on launch instances. I will do this a little quickly because we have already done this for our control plane node. I will change the number of instances to 2. We'll rename this one later. I'll use Ubuntu image, and then here I will choose t3.small, and then I will, in the key pair, choose the one that we have used before, and here I will select existing security group, and this time I will choose the data plane security group. I'll leave this to default. I'll click on launch instance. By the time this instance launches, let's prepare our terminal. I'll go here. I will press Ctrl T to have a new tab. I will zoom in here, and then here session, in the shell part, I will split vertically with current profile. Now what I am doing is, this tab will be for my control plane, and second tab that I have opened will be for my worker nodes. This will be for my worker node 1, and this will be for my worker node 2. I will cd into downloads in both of these tabs, cd downloads, and then let's go back to our browser, and from here we can check out how do we connect to these instances. So worker 1 is this I will rename to worker 2. For the first instance, let's click on connect, and this will tell us the command that we can use. Here I can paste it, press enter. Now let's do it for worker 2 as well. I'll go here, select worker 2, and then I will click on connect. I will copy this, and then in the second tab I will paste it, and here I will give yes, trust on first use. Here as well I'll give yes, trust on first use. Then I will give it a host name. So what I will do is, I'll go to my repository, I'll scroll at the top, and here somewhere in point 4 I believe I have the command that you can use to set the host name. So I'll paste it here, and then I will call this one worker 1, and here also I will paste this, and I will call this worker 2. I'll press enter, and now what I will do is, I'll do a setting which will allow me to run commands in both of these terminals simultaneously, because we are running the same set of commands in both of these worker nodes. So I'll go at the very top here, and then I will choose shell broadcast input to all panes in current tab. I'll okay this, and then I will write exec bash, and then I will clear my screen. You see worker 1 and worker 2. Now let's go to our repository and copy the steps. So we'll disable the swap and set kernel networking first. I'll paste it here, and then this will run in both of our nodes. Then we'll install and configure container D based on the expectations of kubelet. We'll paste it here. This will continue to run. Then again, kubeadm, kubelet, kubectl, we can install in all the nodes. You may choose to not install kubectl in worker nodes, but I am installing it because we might face problems which will warrant us to use kubectl. Hence, I am installing it. But there are scenarios when you will see worker nodes do not have kubectl client. So I'll copy this, and then this is done. I will press Q, I will paste it here, and then this will install kubeadm, kubelet, and kubectl. I'll scroll down, optional but helpful. We want helpful, hence we will also have command completion in place. So let's install that as well. You see all the versions are installed like we instructed. This is good. This command was supposed to be run only in the control plane. We'll skip this. Step 5, install Calico CNI via operator. This was also meant to be run only in control plane node. We'll come down. Here is the command that we will use to join the worker to the control plane node. So workers are with us right now, but those workers do not know who is their brain, who is their control plane. So we'll copy this command. This will give us the token that the worker nodes can use to join the control plane node. I'll click here to the control plane node. I'll paste it here. I think the SSH connection is lost. Let me quickly restart this session. Restart session. Okay. And yeah, I'll cd into downloads, and then I will log in. Let me just copy that command again. Here I am in the control plane node. I'll paste it here, and this will tell me the command that I can use in my worker nodes for them to join this control plane. I'll go here now, and then I can run these commands here. And this says error is privileged user. I will have to add a sudo before it, sudo, and I'll press enter. And this is working. So now let's go to the control plane node. I will run kubectl get nodes. I see worker 1 and worker 2. Their status is not ready. So understand that Calico components, they are running as daemon set. So the pods that are required by that daemon set may still be in not ready state right now. They might still be in container creating state. So let's see kubectl get pods -a, and now all the pods are in running state. So if I run kubectl get nodes, I see a ready status in both of the worker nodes that we just added. And another thing that I want you to note is our web pods are now in running state. Now, why are they in running state? Now they are in running state because now scheduler can schedule them onto a node that does not have a taint, and our web pods also do not have any tolerations defined. Hence, scheduler scheduled both of these pods onto these nodes. Now let's run kubectl get pods -o wide. Both of these are scheduled in worker 2. So let's go to our browser again. So we have just created a deployment. Now we will create a service that can be used to expose this deployment. So we'll be exposing this with a NodePort service. I'll paste it here, and if I run kubectl get svc, I will know the node port which is assigned to this NodePort service. It is 30621. So I will go to my browser now. I will go to my instances. I only want running instances. And then here I will choose worker 1, let's say first. I will copy the public address. This must be HTTP. Okay, just remember this because we do not have any TLS certificates yet. I will paste this here, IP, and then what was the port? Port was 30621, 30621. I'll press enter, and this is still working. Till that time, let's go to instances. I will go to worker 2. I will copy the public address of worker 2, HTTP forwards. It is HTTP // and it was 30621. I'll paste it here. I'll press enter, and this works. This one is still processing. So which one worked for us? It is worker 2 that is working. It is on worker 2. The pods were scheduled on worker 2, but they should be accessible from worker 1 as well. There is something wrong with worker 1, I believe. Let me copy the IP address again. I'll go here, paste this here, and the node port was 30621. I'll press enter. Or maybe this is HTTP and then // why it is not working on worker 1. So let's do one thing. Let me take a rolling restart so of this deployment. So kubectl rollout restart deployment, and the name of the deployment is web. I'll press enter. So this has restarted. If I check this kubectl get pods -o wide, I see completed. Why will an engine export complete? Okay, it has taken one restart. Worker 1, worker 2. Now let's see if it works or not. Oh, it works now. I think rolling restart was the deal that made it work. I will clear my screen. Let's run kubectl get pods now. This pod has been restarted once, and this pod was on. This should not have been restarted. Why is this restarted? Let's do one thing. Kubectl, let me do one thing. Let me create some more pods. Kubectl scale deployment, and the name of the deployment is web. I want this to have, let's say, 10 replicas. Okay, what I don't want to see is I don't want to see these restarts. Why did it restart it? kubectl get pods. Okay, all are in running state, and I'll add -o wide here as well, so that, okay, most of them are scheduled in worker 1. What's wrong with worker 2? kubectl get nodes. Worker 2 is also ready. Let's scale this further. kubectl get pods -o wide. Okay, now it has distributed the load amongst worker 1 and worker 2, and the pod that was on worker 2 has undergone another restart. This is strange. This pod should not be restarting. This implies there is something not right with worker 2. Let's see what is happening here. Because let's do one thing. kubectl, I will quickly check the logs for this pod. kubectl, first let's check logs, and then we'll see the describe for this. Logs, and this is web and jz. Oh, nice name. And if I press enter, it says OS this start worker configuration. This does not give me anything substantial. So let's do one thing. I want to run a describe on this pod too, because it has restarted 2 times, which is not fair. kubectl describe pods, and this is the name of the pod. Pod sandbox changed. It will be killed and recreated. Now sandbox changed. This error pertains to either your kubelet malfunctioning or container D malfunctioning. I'm not sure which one this is. So let's run that again. And if we again see problems with any of the pods, then we'll have to troubleshoot further. Okay, now worker 2 is also facing this, and now worker 1 is also facing this. If I go to the browser, this thing is working, but my pods are getting restarted. Let's give it some more time. Let's see if other pods will also experience this, because if one is facing, then others will also face this. Yeah, there is one more in worker 1 now. So our pods are automatically restarting. And let's run a kubectl describe pods on this one as well. Pod sandbox changed. It will be killed and recreated. Let's run this get pods again. Now I checked the logs of kubelet and containerd. They both appeared to be functioning okay. And then what I also did is I ran these commands. So what we are using is we are using containerd as our container runtime. So if we were using Docker, we write docker ps to see what are the containers that are running when Docker was used as the container runtime. But in here, we are using containerd as the container runtime because Docker has been deprecated since version 1.24. Now, with Docker, we used to run docker ps containerd, so falls under the CNCF umbrella. So what we can do is, for that, we can run crictl ps, which will show us the containers that are running in a worker node. So if I press enter, this will show me all the containers. Now I'll have to also add a sudo. I'll add sudo, and if I run, it will show me all the containers that are running in my worker node. Now I want you to understand a few things. Here you see the attempts to restart have been 0, but when I see control plane nodes, you see that there have been restarts in the control plane nodes pods. Why is it? Because if you look at here, when I rebooted the control plane, the existing pods that were running in the control plane, their restart counter increased, and when I configured the control plane, they automatically had few restarts while the control plane was being prepared. But when I talk about this web deployment, what I did was I deleted the web deployment. I took a restart of all my nodes, control plane node and the worker node, and then I redeployed this, and then I observed it. So if you see, I have been observing it for, if I run, again, this session is lost. If I restart this session, hold on, cd downloads, and if I run the sh command again, if I run kubectl get pods now, you see that all these pods have been running for 20 minutes without any problem. So the crux of my findings is, when you create a new cluster, you allow it some time to stabilize. But once you have run all these commands, you should give a restart to your nodes. And this applies for both your control plane and your data plane nodes. Once the restart is performed, only then run the workloads. And before that, also observe whether the pods are restarting or not, whether all the pods are accessible over all the nodes or not, if you are using a NodePort service. Now let's test what we want to finally test. So I'll run kubectl. Let me go to the browser, and in here what I will do is I will create a NodePort service. I'll copy this command, I'll come here, I will paste this command here, and then it says already exists, so it exists. So let me run kubectl get svc, because I didn't delete the service, I just deleted the deployment, and you see 30621. If I go here, 30621 was the same. If I hit refresh, here, let me check the IP. Oh, it is working, like you see. This also works and this also works. So there is no fun in creating a cluster in one go. I have practiced at least 3-4 times before recording this session, and each time I was hit with a different error. So which is why what I have done is, if you go to my repository, I have listed down few of the troubleshooting steps. Now, if you are stuck somewhere, if you want a clean slate, do not just recreate your servers. You can always run these commands in your respective nodes. For example, if control plane is facing some problem, you can run it. This will clear all the installation that you have done, and then you can refollow the steps. But again, the crux is, once you have done everything and it looks like everything is working as expected, I would still suggest you to perform a reboot. And I have checked various sources before making this statement. Perform a reboot and allow cluster some time to stabilize. Now, once you are done, remember to delete your cluster. And with that said, that's a wrap for today's lecture. We built a multi-node Kubernetes cluster with kubeadm, containerd, and Calico CNI. Next time, we will upgrade this cluster step by step so you can practice day 2 operations with confidence. If you have any questions, feel free to ask them in the comment section and I will reply. If this helped, do consider liking, sharing, and subscribing. It will mean a lot to me. Thank you very much.